Hello everyone, welcome back to my channel. So the other day I was at Walgreens doing some shopping when I noticed the discounts offered to Rewards Club members were absolutely insane. Well, not insane, but quite enticing. 2 KitKats for $1.50 or 1 for $1.15. What made this really stand out to me was when I thought about it and realized just how much of a difference in profit this makes. In a case of 36 KitKat, the total sales could be anything from $27 to $41.40, meaning that the amount of money that a store could potentially be losing out on per case is $14.40. Multiply this by the number of boxes that a store must go through and the number of stores all over the country, and the potential amount of money lost is huge. And it's not like everyone who shops at Walgreens has one of those cards, or else listing the non-member price would be pointless. So what exactly could entice a corporation to offer discounts to customers just for signing up for a little card? The answer is actually quite broad, involving obvious things like customer retention, customer acquisition, etc. But what's really interesting is that the often most overlooked thing that companies get in exchange for discounts, giveaways, and things like that is data. The volume and variety of data that we give away to companies is quite simply flabbergasting. Let's just look at 2 simple questions which might be answered using data. First, suppose a large grocery store is wondering whether or not opening a new store in another area code could lead to attracting a whole new group of previously untapped customers. Well, since we have all this lovely data sitting here, let's look at what we might be able to conclude from it. If there were indeed need for a store in a new area code, then what we would expect to see in the data is a lack of customers from said area code, which is usually a required step in getting any rewards or membership card. This, combined with census data showing that the areas are not very different socioeconomically, culturally, geographically, etc., would make a strong case for expansion. On the other hand, if we are wondering what kinds of products to stock in a completely new region, then looking more closely at the data could shed some light. After studying the potential new location, we might have a picture of the environment. We can then begin looking through our existing stores to find locations similar in as many categories as possible to our potential new location. For instance, after finding a good location in a mostly rich and mostly white neighborhood in the cold northern Midwest states, one might look at any locations in the northeastern part of the United States that is also mostly rich and mostly white to determine what kind of products are good candidates. But so far, everything that we've covered is small potatoes in the data analysis game. This kind of analysis involves people making charts, talking to each other, and making decisions, which could take anywhere from hours to years. On the internet, however, analysis of data needs to happen thousands of times a second. The classic example of this is Amazon. Now, since just to order something on Amazon, you need an account with your shipping and billing information, the amount of data that Amazon can mine from you is astronomical. By going through the data for millions of people, Amazon can create groups or clusters of customers that it deems similar. If, for instance, you bought a carrier and a leash, Amazon might group you with pet owners and suggest things that other pet owners have purchased. If, however, a large percentage of those who purchased the specific carrier and leash that you bought went on to purchase dog-specific items like dog food or toys, then the system might associate you specifically with dog owners. The degree to which this will be accurate depends heavily on how much data they have on the people who purchase those items and the number of people it has data on, since obviously having a single known pet owner make a purchase of a particular item doesn't necessarily mean that the item is even intended for a pet. However, if, for instance, millions of known pet owners purchase a particular item and there seems to be no other similarity between them, then suspecting that the item is appropriate for another pet owner is quite reasonable. Something that's really important to note that makes this different from the kind of analysis that we talked about with the grocery store is that this clearly cannot be done by humans. Amazon would need to employ the entire human race to even have a chance at doing this with humans. So instead, Amazon does this by automating the process. This is called machine learning, and it's essentially a form of AI that gives computers the ability to learn without being explicitly programmed. These kinds of algorithms that predict the future based on data are labeled unsupervised. Another example is Facebook, analyzing its users' actions to find patterns. For instance, if while viewing your feed you stop to click, like, or comment on posts from a specific person, then activity from that person will begin to appear in your feed more often. In addition to that, Facebook also uses the information of the content that users stop and click on to make money through advertisements. If, for instance, you tend to click on products related to health and fitness, then Facebook can use that information to target you with ads for things like health supplements or workout equipment. Other websites, like Twitter, hire companies that specialize in programmatic advertising, meaning they take Twitter's data and use their own proprietary systems, software, and analysis tools to auction off advertisement space in real time. What this means is that when you load up certain pages, every space that can have an advertisement is put up in an auction, and based on the information the system has, companies bid based on how much they expect they can make off of you. This happens to every space on every page for every person that uses this service. As you can imagine, this requires the analysis of a huge amount of data at lightning speeds. Overall, this is truly amazing work that requires a huge amount of effort to create and maintain. If you're so inclined, please check out my last video on how many different kinds of burritos there are at Chipotle. Part 2 of that video will be coming out next, so stay tuned. Don't forget to like and subscribe, and I'll see you next time.